my fellow YouTubers. This is Roy back again. Welcome to my live broadcast. Here we got Ed Leedskalnin's replica, V-shaped magnets. I got a good charge going on them. I only used 12 volts to charge these. So let's go ahead and I guess what we can do is we'll do a test, a magnetic Gauss test on these magnets, and we'll see what their poundage of pull strength would be. On top of that, I have some iron rock, and I got some magnets. Got tape right there. That's the south side. Okay. We're going to do a little experiment with these magnets and these rocks. So tonight's live broadcast is kind of going to involve a couple different tests. One, like I said, we'll do a Gauss test on these magnets, the V-shape, and we'll check and see how much pressure it takes to pull them off, okay? Then we have these magnets, just earth magnets, and we have some earth rock that's iron, and rock and iron, pretty cool stuff. Also, right here, oh, we gotta move you over a little bit, guys. Right here, I got a new PMH I just built. Now, 16 gauge, sweet 16, right? 16 gauge, and I got those wound 400 turns each. I used that counter winder thing I have. Worked perfect, guys. Haven't figured out a guide yet, but I use my finger and just work with it. 400 turns each. And let's start off with these guys. Because what we're going to do is something of how... we're gonna do something now that that shows you in number, not only turning, not only making electric, but some ideas. And you guys that watch me, I appreciate it. Hopefully our internet stays on tonight, and we could have a great show here, because there's different things here that, not saying Ed did it, but there's things here I see with this wheel that has potential, so we're marking them down and writing them. But let's start off with simple stuff right now. All right, so I wrote this out, and can you see it? I wonder if the glare is too much, but it's EIR. So E equals voltage, I equals current, R equals resistance, okay? So we're going to go ahead and we're going to start off, and we're going to check what 416 gauge wires has in capacitance. So I got a bridge rectifier on there right now, full wave, but that's an experiment we're going to do. I hate to undo this and do that, but to tell you the truth, it's all good to experiment. I love doing this stuff, guys. If you do it at home, I hope you really like it too. It's just to learn, and just to, it's all about the numbers. I'll tell you, it is. It really is. Full wave bridge rectifier. If you haven't made one, look it up online. Is you take the rings. Start off by putting the rings together. Like, let's go to the right one. Okay, here you go. So start off putting the rings together, and then take the back one, follow that ring, take this one, follow the ring, and tie those two together. That is a full wave bridge rectifier. You got that? You got your two rings are facing each other. And then you got one following, they're tied together. It's a full wave. This right here is the positive out DC, negative out DC, positive in AC, negative in AC. Sorry about that. Negative in AC, positive, DC, positive out, DC, negative out. some cool stuff here. So we'll put that to the side, and let's go ahead and hook up one coil. So this coil right here, we're going to check and see what we have in resistance. So we'll use a regular voltmeter. Okay, regular voltmeter, and we'll change this over here to where you hear a pinging, so there's a connection, and the resistance is 1.0. Okay, so 1.0. So resistance is 1.0. Okay. Now let's go ahead, and what we're gonna do is, hey, you guys, leave your comments. Who's on? Give me a shout out. I'll give you a shout out. I see 2 people watching, so leave a comment. I can see who you are and say hi. But anyway, so let's go ahead and tie these 2 together, okay? And what I mean by that is we will take the in on this one, okay? That would be the start of this coil. And we're gonna make that go to the out of this coil, okay? And what dictates that is how this coil and that coil is wound. Now these coils are all both wound in the same direction. So you can see the reason I'm going in the out is because the coils are wound the same. So we're reversing the poles on the 2 coils here if we were to dead short the other 2 ends. So now we got the other 2 ends here, and we're going to make the connection here now. And we're going to check and see what resistance is in these 2 coils tied the way I have them in there. So let's go ahead and put the positive on the way out, and let's put the negative on the way in. All right, negative on the way in. Now we're going to go back, and now we are at 2.5, 2.6. Let me turn that off again. All right, let's go ahead and give it a whop. So we are at 2.3. Moving the wire, I guess, but it's 2.3. All right, so 2.3 we have, so we're gonna do 2 things. Is coil A over here, okay? Coil A, which would be the 1 single coil, was 1.0. Coil B is 2.3. Okay, big difference there. But I mean, what we gained is, so individually, let's check the capacitance in the other coil for shits and giggles. Hey, all right, I got some boys out there. What's up, Adam? Let's go ahead and disconnect the center here, and let's go ahead and check the resistance on this coil now. Okay, and we're gonna bring that back over here, and we're checking the resistance, and the resistance on that 1.1. Okay, so that 2.3 that we got with both of them tied together, in a sense, balances out. Okay, so you got 1.0 per new PMH that I made. Now with that resistance, I put it over there in the R category. So I did it as 1. It could be 1 or 2.3. Depends if you're going to go bang each coil with 12 volts, or you're going to spread out the 2. Because here, like I said, you would tie the start here to the end here, and then these 2 here you tie together. And if you bang those 2, you're going to get south and north present on the prong ends of this PMH right here is what we're looking to do, okay? So, so that we have. So we're going to try to figure out, the reason I'm doing this, we're going to try to figure out how much current that these guys are going to absorb out of my 12-volt battery. Very important to know how much power we're using before we even get in the game. So here we are. We're going to go over and we're going to the E, we're going to add the volts. So volts, we're going to, one battery's 12 volts, the other battery's 24 volts, which really they're 13.3. A car battery will hold as a filled battery. So you know, guys. So we got 12 divided by 2.3. Damn, I don't have a calculator on me. Can't use my phone. We got to do numbers. I need to do math. I already know it's 6 amps. But, so that means so it's 6 amps. It's 5.9 something. So it's 6 amps for, not this one. The 1.0 would be half of that. So that's 3 amps. Okay? 3 amps we're pulling with one of these coils. So with the other coil, we're pulling 6 amps. Okay? So we're stuck at 6 amps every time we pulse this. Just so you know. And it's not on all the time, 6 amps. It's pulsed. Okay? So this is how you figure out one leg of this whole wheel on different aspects. But this right here at least shows you that it's going to pull. If I use one of these as a moving mechanism for the wheel to turn, okay, that means I'm using 3 amps every time I tap this. Now, for instance, this other one, I don't need to pull the wheel. I could collect the back EMF off of this one here. And let's go ahead and check and see what we get for the back EMF, okay? And then we could start to use the numbers to guide us into some of the experiments here. And I hope you guys appreciate the experiments, but right now, this is the first time I'm ever taking the wheel and really working on numbers and really everything. And there's some good comments out there, especially Tommy. Tommy, are you out there? Leave a comment. Tommy, you out there? Hey, Adam. Oh, hell yes. There goes Adam, my boy Adam. Adam had given me a couple drawings on Ed and the whole thing with the pipe and all that. And I love it because he really has it laid out in a beautiful way. And I think that is like the framework that we're using. But Tommy has presented out there something I felt the whole time. And that was that Ed talks in magnetic current. He talks about different experiments. And one of them was how the magnets shift over to a corner and concentrate. And they build up. And how that happens on the ends of the magnet. And then he talks about hardened steel, and then when you harden the magnet or harden the metal, that the prong end here, when it's hardened, will get smaller, but it'll get dense. And what happens is those magnets get bunched up and dammed up at the ends. You guys get me on that? That the ends right here get dammed up. So if the magnet ends are getting dammed up, and then your circulation the magnet and around, and then then you have it actually comes out. And I'm excited because we can in different phases I can show you with the thing, the green, what is it called? Yeah, it's called this guy. So you can see on here the magnetic field. And the magnetic field comes out and it comes around. And also in between it here on these prong ends is all going across. So you sort of have like a coming out, coming across, going across. And this is only in the ends, the prong ends, guys. So interesting stuff how these magnets work. But going back, I guess I lost track a little bit. Sorry about that. But going back to Tommy's comment, how I felt was, if you read the last video and you could read his comment, I always felt that the center was important. And through through Ed Leedskalnin's writings, excuse me. Whew, excuse me. Whew. Anyway, that was a sneeze of all sneezes. So in the center, when the magnets are in motion, the ether is going to react to the magnets. So you put this wheel in motion, and it probably don't have to be too fast, but whatever the speed is obviously related to sequence. But when you would turn the wheel, the ether itself, as Tommy explained, would be like each one of these magnets here, north or south, would be like a trap door. And once you come up and look at the trap door, it sucks you in. So Ed explains how when the magnets dam up, it's like a stadium, basically. And they're all bunched up. Now you start getting circulation of the wheel. The key element with the dammed up magnets in motion is to have the center drawn in, having a coil in there or several coils. I'm not sure. I got to think this through, but having a coil in the center would give direction of that ether with the magnets to be always coming in, and then the dammed up part here would stop it from coming out. So you have only a one directional coming into the center of the wheel. So that means the center of the wheel needs to be a coil. And you do have, Ed's does have this shaft that comes up from the center. So that means that the body of the iron of the motor is bound to the shaft. The shaft would have a coil around it, because that shaft right there is also connected to something like this, which exactly that. So if you ever notice, there's a key coming off here. And then there's 4 bolts coming down into the magnets. Don't know what all that is about. Nobody knows what that's all about. Leave your comments if you think you know what that is all about. But we're going to get there on work, talking it out and talking it in, because the energy from the wheel in motion, ether, is getting absorbed into the magnetism. Magnetism is being drawn to the center. So Ed talks about in his magnetic current, or actually he talks about boys and girls in a Book in Every Home. And something that intrigued me with the Book in Every Home, there's references in there. And Ed's like challenging us with that book. He's challenging us. Anybody ever read a Book in Every Home from Ed Leedskalnin? Leave your comment. And also magnetic current. And I would have to say that a Book in Every Home looks like this, okay? So there's a book in every home, okay? Then there's magnetic current. Ed threw it out of my hand. I'm just leaving it like that. That thing got thrown out of my hand. So anyway, so there's magnetic current. And I'm glad the internet tonight is staying on. Yeehaw, NASCAR. So in there he talks about boys and girls. And I have a friend of mine that I knew for probably 20 years now. He's a homeopathic doctor, I'll call him. And firm believer, okay? But anyway, he always said that girls had a negative charge. And there you go. Girls have negative charge. So when Ed's talking, he's talking about the pull strength between positive and negative, okay, on the V-shaped magnets. He's talking about pull strength. And he's saying that the south pushes more than the north pushes. And the north pulls more than the south pulls. And when I think about the homeopathic that girls are naturally negatively charged, they're pushing you away. They're pushing. They're down on the ground, pushing up, right? It's a girl. It's a girl charge. And a boy charge is the charge on top, and he's on top. It's crazy how you can think about this, but just the dynamics of a boy and a girl, and then the dynamics of the two charges and how they react to each other. And this is what we're getting at, because this is all about spinning magnets in motion. And now, I'll tell you the truth, guys, who else has the wheel, and who knows how to make any of this damn work? This is like revolutionary evolution, because we don't know this shit. Maybe the military does, but I don't know. It's interesting stuff. So it's theorized too, because we don't know what Ed did with the wheel. I believe he had the wheel. I don't know what I believe. Tell you the truth, there's so many different things, and you kind of want to believe things that he kind of pulls you into it. But anyway, energy coming in from motion of the magnets. The energy is coming in and being pulled in and directionalized. So if you had a coil in here in this core, okay, one side of the coil would be attached to the ground, and the other side of the coil should be attached to the chains. What makes sense is if you look at Ed's picture, the chains have to be a positive charge. All right, see these chains? All right, chains, all positive charge that's coming from that box down there. That box producing a positive charge. Now what he says is, he shows you how to make a magnet. He shows you take one of his experiments. You take a piece of copper wire, you put a positive negative charge on it from the battery, and then take a piece of iron rod and put it 90 degrees, guys. Remember this. 90 degrees from all the way, you get a north and south. If you stop it in the middle and pull it off, you'll get a separation of charge. So actually, that one rod will have four poles. It'll have a positive, negative, right? And then it'll have positive. So it'll have a break in the middle. And we'll get into that in the future. But so with Ed's wheel here, everything up here is a positive charge. And notice this, the bike and the chain comes out. So the chain comes out of the box. There's also a wire right there that comes up and goes to this apparatus over here. Notice the chains here are touching this apparatus. That apparatus is sitting on top of the pipe. Now, probably isolated from the pipe, I would assume. And then the chains come down around the bike and come around and come back up into this box. So the key thing is to get a current. In order to get a current, you have to direct the energy to move. So if you have the energy in these magnets, for instance, they're just in there. But he's showing us in different experiments how to move the energy. And you have to have one chasing the other. So if we just do this, let's go ahead and go back to, let's check right now. We are going to volts, and we're going to check the back EMF off of this coil, and we're going to pulse this one and just move the wheel a little bit. So let's go ahead, and this is what? This is the end of this coil. Is the positive I'm making it, and then the negative will be that side. So this coil right now is up to the voltmeter. Can you guys see that voltmeter? Make sure you can. This side we're going to tap with 12 volts. Fire in a hole. So we're going to go ahead and put the positive of this jumper cable. Okay. Gotta be hooked right. Jumper cable. And then the negative is sitting right here, and we're going to tap. So what we're going to do here is I'm going to move the wheel. Oh, shit, guys. I'm going to apologize already in case it happens. But if I move the wheel, it might knock out our internet connection. But I'm just going to move it lightly, okay? So right now we know this is south. This ain't doing nothing, but negative does show up here, but it won't have the pull strength or the push strength. The pull strength that this side of the south would have. So this right here is the tape is south, and the no tape is north. So if that's south, we want the north to pull towards it. So we should get, oh no. So we get it going like that. All right, so now we're gonna look at the voltmeter, and let's check and see. Let's check and see what volts we get back. It's a little hard to do, but I'm only seeing like 1.5 volts max as a back EMF. You can see the wheels pulling now. One thing about this build, which is different, that I like is that this south here will push away the damn south. Instead of metal to metal attracting it, that's how I got the wheel going before, just metal to metal. Now it's reacting different. Everything is coming different. So that pole and that pole right there is the same. Now this pole here and that pole is the opposite. So you get the sucking. But watch now, watch. It'll barely push. It's close enough to attract a little bit. It's metal and metal. You can see it push away. Now watch what happens now. It's a little more responsive. So we only got about 1.5 volts back EMF. That's not impressive. And that shows you that this is less resistance than these big giant monsters I have over here. So more resistance might be needed on the back EMF side. Okay, like this coil here, the pickup coil, not 16 gauge wire. Maybe, I mean, we do want current to come from it because we're going to reuse that power. So maybe 18 gauge is the better wire, or more turns, which I could probably fit another 300 turns, 200 turns on there. But I'll have to do the numbers and check it out. So, all right, so here you go. So you got that coil, back EMF coil. Now we'll take it out of the back EMF, and we're going to go ahead and blend it with this coil. So this will be south, this will be north. what we're going to do is keep that south coming in there. We're going to come out of this coil and we're going to go into the end. No. Wait a minute. I'm a little confused. I apologize. So what we're going to do is connect these two, which is the start and the end of this guy. And then we're going to go ahead and connect these two together. And then we're going to check it, but I'm pretty sure that here's our checker guy. Here's our compass. Let's go ahead and come in here with the positive. I'll come over here with the negative. So right here, I don't know if you can see it, but man, I yanked the wheel and get my finger. So that's north, that's south. Look at the bell coming over. All right, so guys, watch how responsive the wheel is now with both of them. Now remember, the way this is set up, this is only one only 0.10 ohms. So this is pulling 3 amps. So we got 3 amps going through this right now. See how quick it throws this wheel around? But just look how responsive. Also look at the bell reacting. See the bell? So very responsive. Now, let's go ahead and do another experiment. You guys want to do another one? Hey, what's happening out there? All right. So, leave your comments. I'll look up and see if I can read them. Sometimes, you know, I get a hold of them. I got to get my laptop over here so I can just read the comments and answer back to you guys as you're commenting. So, you got to see the new PMH. You got to see that by going each one individually or going through both of them, how it responds, how you got a lot more magnetic power. And also, we're building 2 of these. And let's go ahead now and do a magnetic pull strength. Let's do a Gauss on this son of a bitch. So here's your magnets right here. What's up, Adam? More cowbell. Oh, you like that cowbell moving. There you go. That's my Benjamin Franklin experiment with static. It's cool as hell. The bells ring when the air outside gets static. What a great concept. In fact, it's got me intrigued tonight because, you know, we're going to do a Gauss test right now on how strong these magnets are right now. Remember, they're only halfway charged. I usually charge them with 24 volts. I like to get 36 in them and maybe a little less amperage. So now we're wounding coils. Now we're wounding coils with knowing exactly how much amperage that's going in them. I can play with this and make some different coils. And then maybe control a little bit more of how strong these magnets can be charged up, all right? So back to the Gauss test. So over here I got this bar, steel bar, and we're gonna stick it. Gonna stick it. Let me see where you guys can see this. So I guess right there. What's up, Scott? So I got this little meter that's just a little scale. It's a hanging scale, cheap, $4, and you pull on it, and I got it in poundage. So we're going to go ahead and we're going to pull on this until it breaks free. You ready? You ready, guys? I'm going to pull on it. And right now it's in lock because I stopped. But let me turn it off. Turn it back on. And we're going to give it a pull test. And we'll see where it... Right now we're at a pound, 0.97, 2 pounds. 2 pounds. 2.9, 3 pounds of pull strength. So 3 pounds of pressure these magnets hold. Not a lot compared to neodymiums. It's crazy, right? So, do I have the U core off the center? What do you mean by that, Adam? The U core off the center. Talking about the PMH? Adam's leaving a comment on it, you guys. Hey, listen, do me a favor. Somebody out there, go ahead and... That's not me. Oh. Sorry, Adam. That's Scott. What's up, Scott? So, somebody out there paste and copy and post all the comments for me. I love reading them because I go back. Yes to PMH? All right, cool. What's up, Cam? Yeah, actually a reed switch. And the reed switches, Cam, are easy to make all by yourself. And the thing with this now, before when I had it run, I was hitting each one of these and it was killing the magnets. And no problem, Adam. It was killing the magnets. And I knew Ed's wheel, the magnets were still intact. They were still strong. So he wasn't doing it to turn the wheel. And now when I charged this and built this the way I built it, for some reason, the positive and negative of the PMH is making the wheel react exactly how it's supposed to be. Maybe because I'm back in spacing a little bit more. Because when you're up real too close, it overpowers whatever these are, positive and negative. But right now it's acting really good. So to get this PMH turning the wheel, what I'm thinking is 2 of these, and one of these is the mover, and one of these is the back EMF. The same thing with the other PMH. One's a mover and one's a back PMH or back EMF. So basically 2 of them. You've seen the strength of the 2. So 2 of them were doing the job moving the wheel effortlessly. And the other 2 are collecting the back jolt off of the saturation of the core. You guys are commenting pretty good out there. Make sure somebody paste a copy of these and put them on the video when the video comes out, please. So there you go. So you got your pull strength over here we just did, and that was 3 pounds. So let's go a little deeper, and let's go into something that I wanted to do. So let's go into these rocks. Okay, this is a magnetic rock. It's a damn iron rock, and it's magnetized, magnetite. I guess they call them magnetites, right? Here's a magnet sticking to it. Some areas are more concentrated, some areas aren't. All right. Let's go ahead and check with the compass. So somewhere on this rock, there's your south pole in this corner. There's your north pole over here. So north pole's over here, south is over here, okay? Now, let's go ahead and... Damn, I would really use a Sharpie right now. but we're going to use my crayon for welding. So right there is the line, okay? So let's check that. Make sure I didn't move it. So this side's the north or south. This side's the south. Here's the south. Oh, that's north over here. So my line was off. All right, so there's the line. That way. So there's your south, there's your north. All right, let's go ahead and check that. Come on now. There's your south. All right, I'm kind of freaking out here because this rock ready for this? So let's go ahead and get a magnet. Remember, that's south and that's north. So we're going to take the north part and we're going to run it and slide it across that rock. I can tell you it's active. I charged that rock. So there's, it's saying south. It's saying south again. Let's try that again. This time we're going to take the opposite side. We're going to run it from one end across the top. All right, so this is your north side, that's your south side. Now let's go ahead and reverse this so far. We're going to flip the poles in this rock, which I think is unbelievable. And we're going to, this time, go from this side, and we're going to swipe back. And we should have this side be the north. Look at that, guys. Look at that. There's the north. This side showing the north. This side showing south. Let's do that again. Let's come flip the magnet and let's go that way with the magnet. Is this side north still? Nope, this side's south. This side's north. Cool stuff, huh, guys? Reversing the poles in a rock. In a damn rock. In a rock, guys. Changing the molecules in the rock. Re-angling the molecules is what you're doing in a rock. In a damn rock. Unbelievable. Unbelievable. And then speaks about that in his stuff. He speaks about it. So where are we at here? All right, so we did a Gauss test. 3 pounds, right? We done PMH. We figured out how much current we're gonna have based on our ohms and our voltage. Now remember, if I double the volts to 24 volts, this becomes 12 amps. It's a lot of power. Too much. It's too much. Too much. The whole key here, I think, is trying to make the wheel turn in a conservative way. So by knowing we're going to pull 6 amps a current, whether I pull 3 in this one and 3 over here, 6 amps is the job to get the wheel turning. The whole key is to get the wheel turning. I'm not going to sit here and spin it. You know, I could hook an electric motor up to it, but we're going to do it at Leedskalnin style. Also, the magnets in a vortex. Okay. Get everything out of the way. So, turning the wheel. One thing I wanted to tell you guys is, you ever notice with weather stuff matters. And the reason I say weather matters is because on the northern hemisphere of our planet, we're turning counterclockwise, clockwise. And then below our hemisphere, we're turning counterclockwise. I believe that's it. The cyclones and hurricanes, they're turning the opposite way. So with coil winding, as you can see here, with both of these wound the same direction, I have to go into this other coil the opposite way I normally would go in there. I would take the 2 starts here and bang them the same. If the coils were wound the opposite way, this would be one pole and this would be another pole. But by having them both wound the same way, that I have to be smart enough to know that I have to reverse that pole. And you can figure that out too, guys, on your PMH by just putting a compass in front of them without the wheel involved, and just touch them and then flip the poles and touch them, and just learn that way. I mean, that to me is the only way to do it. So we learned that in the coils that you can reverse the poles. In the storm, the direction of the wheel either has a center pressure or an outwardly pressure. So turning the wheel clockwise, like our hurricanes, I believe our hurricanes in the northern hemisphere have an outwardly internal. The typhoons, eastern part of our hemisphere, are stronger wind-wise and everything. The winds go up to 400 miles an hour, guys, even more than that. It's because there's an internal, and that's the turning it counterclockwise. So turning this counterclockwise should pull in the energy of the ether, because we have a magnetic field that's going. Now follow me, guys. We got a magnetic field. We are now building an inward pressure. Now, if we had a coil on the inside that was absorbing, now I'm talking about a coil that's probably going to have to be up close from the center core and goes out. So probably the height of the 4 magnets, okay? Which, let me get my yippers. I wish I can't have music on. Can't even have my headphones on, so I wouldn't be able to talk to you guys. Yeah, my tape measures here anyway. So for these magnets, just say that's 4 inches. All right. So that coil needs to be the top to bottom of the magnet neutrals. And it needs to be wide enough to come all the way out and be probably a good 1/8 of an inch. So it has a close magnetic presence to the back part of the PMH. And as that explains, that the ends of the magnets get dammed up. So the energy is not going to be able to escape. It's going to be trapped in, sort of like a dioid does, where Well, a dioid allows one charge to go through. Um, each end of these prong ends are a separate charge. So if they're both coming in, this coil in the center has got to be able to split those two poles coming in. So it'll send one to the chassis, to the body, the metal body, of the wheel, and then the other charge would be the positive, which this ring in the middle here, can you see my finger? That ring there is isolated from everything. So it's a place where a positive charge could run free in this environment, with the top clover and everything else being negative. Sort of sandwiched. Sandwich the positive in the center, sort of like the equator. If the equator was the power of our planet, it would be pushing outward. And I believe that's what creates the two poles on our planet, and I believe that's what gives viability to the flat Earth theory, that the energy is from the equator coming north and south, and the pole expansion is how far the planet's atmosphere stretches out. So leave your comments on that, guys. Hey, what's up? What's up? What's up? Tommy in the house. So, yeah, so leave your comments, and that expansion and attraction is what you need to take that energy and suck it in, dam it up at the ends, allow it to get absorbed up in that coil on the inside, separate the charges, that's the chains and everything, and get the positive to come out, because the positive is going to come out mainly through the box that's down here. Let me see, you get down here, there's a box. So you're taking the positive charge through the chains and running back up and keep it at the top. And that's where my boy Tommy here was talking about the chains being a positive charge and the hook hanging from the chains. This guy right here. This bar here is bolted to the hook hanging down. Could be just as enough distance from the side of this metal to be a spark gap or a safety gap, basically. This is what's good about learning Tesla stuff. There's a reason why you do safety gaps, so you don't kill yourself. So this top of this handle, which I happen to have right here, and a sleeve around the handle. Now, the outside of Ed's handle is copper, by the way, you guys know. It don't look like copper, but it's copper. And there's a gap that's between that hook and this. But the thing is, this isn't stationary. This is an orbitable situation. So you could have your mediocre gaps coming through your safety gap, and then every one revolution you got a bang coming from here. But who knows? And who knows what that even is going to do? Let's just break it apart section by section. And my boy Adam up there that's watching right now had a great idea about, he sent me a video what was it? It was for magnetic amplifications. So basically, we were taking, where was it? I got it written down somewhere. Somewhere. Here it is. Magnetic amplifier and a detachable reactor. So these are the things you see on top of Ed's picture. Those things right there. And then there's the pipe, and Ed has the coil up on the wall, so that there's a coil going down the pipe. to make a saturable reactor. So in order to make a saturable reactor even work, or a magnetic amplifier, you would need a positive. You'd be mixing positive and DC, and you would be controlling the positive and DC. You need AC and DC, and you'd be controlling the AC by a small current of DC, which is unbelievable to think about how that amplification works and how it's a controller. So I think that has a play in here. I really think the controller has something to do with this. The pipe, you know, let's talk about the pipe. So the pipe is a saturable reactor. So that means we are taking these magnets, we're sucking them into the coil, and then we're running them down to the ground and energizing the pipe, so we have a good storage of energy to bang. We're going to have to get in the conversation with the bang here with the pipe in the ground. And I've been doing a lot of research. I haven't been on doing any videos in a few days because I've been teaching myself about what was it? It was superconductors was one of them, and the other one was just the I guess the amount of resistance that our Earth has in it in the material. So here we go back into atoms and elements and stuff like that. So it's just all over the place. So if you're asking me how come I'm still with this wheel and still not figured it out, easy peasy, guys. There's nothing easy here. There's nothing to figure out except for the dissecting part, which we know we're working on it. We are sure working on it. Sure working on it. The man, the myth, the legend. I think there's something here, and the something could be twofold, threefold, or fourfold. The something here is, this is just a magnetic wheel. If you talk to people who are trained electricians or trained engineers or physicists, these are just magnets, okay? But what happens when you take the magnets and all of a sudden you put them into orbit? Well, that's what the PMH does. For instance, let's do an experiment. Well, I got you guys hanging out here. Here's a big ass PMH. This thing has got some serious something about it, okay? Serious. Now let's throw 12 volts in this sucker, okay? And you see the prong ends are connected, sitting right on top of the pipe. I guess we're gonna get this heavy guy, the keeper bar, okay? Let's throw the positive on this end. Let's bring the negative around. That is a heavy, heavy bar. Heavy bar. Heavy. Now, because these prong ends are touching this top here, this whole top has got to be getting charged. So let's see what we can do to isolate it. Can you see if I come over here? No. So let's see if I turn you. There we go. All right, so we're gonna put the PMH. That was hard to pull off of here, by the way. So this metal right now, these rings, got the juice running through them. There's no disconnect. There's no keeper bar in the rings. That's another thing I wanted to tell you guys, is that these magnets get stronger because the energy is trapped in not only the clover ring, but the other ring and this ring. So now we're gonna get this again. And just Ed's concept about perpetual motion. Ready? All right, let's see what we got here. So we got a bar that's probably too heavy for that one. That's the bar for this frame, for this PMH, the 1.5" stock. So I guess I could maybe, where's that other one I had? Try this one. I'm trying to lift the sucker up. I should have enough in here to lift it. So anyway, there's your perpetual motion. So you have the energy running around in the bar, racing around. In retrospect, we're trying to create the same thing in the wheel. Okay? In this PMH, you got it racing around. The bar's attached. There's no energy that's being pushed in here to keep the bar. This is soft iron. So taking the premise of what Ed showed us with this PMH, we got to look at the wheel as the wheel part absorbing in the energy. There's got to be something that drives the energy inward. Everything goes to the center, right? Everything goes to the center. Everything. Give me 2 seconds. I'm going to go ahead and just grab something real quick. And leave your comment. Make sure one of you guys paste and copy these comments and put them up and post them on our comments when the video comes out. I'm going to read them all because it's good read. You guys are leaving great comments. You're talking about great stuff. It's bringing up a lot of conversation. That's the whole key with this channel here with live. It's a conversation. And one even better, I like to have it to where you guys can call in and we can have all listen to somebody's responding on different topics. NASCAR. Alrighty. Let's get down to it. So where do we go from here? Talked about the coils. Got the PMH here. Still stuck. Still got the bar on it. Talked about how much we can charge the V-shaped magnets too. Remember Ed talked about just don't damp, you know, I mean, don't, the magnetic strength didn't matter, but in quantity they do. So I think that's where the stacking of the magnets, and so far I've seen that the magnets, when they're piled up, they're stronger, a lot stronger. You guys are rocking on your conversations, man. That thing, the screen is moving fast, real fast. Right there. You guys got a good visual, right? So I hope you guys liked the show. I don't know what else to show you. I don't know if you guys can see that. The magnetic field comes all the way out. You guys want to do a good sample right now? Let's get some metal shavings. I think we'll put metal shavings. I got a good idea. Hold on. Need some metal shavings. All right. Metal shavings. All right, got some metal shavings and got this container. Let's take the shavings off of here and stick them all in. Yeah, dog. Metal shavings. So we're gonna run the magnets. We're gonna put this above the wheel. Let me get a little bit more. Let me get some more. We need a little bit more. We need more cowbell. Give me some more cowbell. More cowbell. Yep. More cowbell. So let's get some shavings here. Look at all the shavings I got. Holy cannoli. This was a good score. This is my drill press. Look at all them shavings came from my drill press. Somebody's been hard at work. Mixed in with a little sawdust, but that'll never hurt nobody. All right. The white stuff is sawdust. The rest is metal shavings. Little itty bitty ones too. So let's go ahead. I guess, is that a good place for you guys? No, that's outside. Let's see. You see this? Good spot, right? Is that a good place? Oh shit, look at that movement, guys. All right, so let's start seeing what direction. All right, I got something better to put it on. Let me see what I have. Can you guys see this? Good. Notice this. Wheel spinning that way, magnets coming back this way. Look. Currents this way. Look at the flow. You guys see that? Look at the direction. Look at the direction they're going. Fuck. All right. Stupidly, I get a magnet, pick it up, guys. Don't worry about it. So now, let's spin it the opposite way. So now we're gonna go this way. Look at it. Everything's going that way now. Let's change it. Oh, look at the magnets. Holy crap. All the magnets got a beard. Hey, the magnet's got a beard. So you can see the direction. So magnetic field's running this way. Matter is coming towards it. Now think about saying to you guys, matter, the ether, is running like matter towards. That's running towards. That's running towards that way. So tell me, what direction would you make the wheel spin if you wanted the energy to come inward to the center? Inward to the center. Inward to the center. Let's visualize that. Inward to the center. Wider. Remember, we're going to come all the way out, close in relation, just like that. Close. Look how that one's spinning around. Let's check another thing while we're at it, guys. Let's look at my materials box. Okay, got mica. Anybody out there think mica is going to respond to an electromagnetic field? I know it does electrostatic. Let's put some of that in there. And this right here, we'll put in. I guess we'll have to throw a little rabbit fur in there for good luck, guys, all right? Let's see what reacts, if anything. Spread that out a little bit. Spread that out. We're going to start off with this one here. All right, well, you already see something moving. That seems like metal. Look, it's like ants. It's like alive. Is that crazy? Oh, wait, hold on. There's other stuff moving. Oh, shit. That ain't good. I need something to lean it on. Too far. It's always something. Give me a second, guys. We'll get this figured out. I wasn't born from no hand job. All right. This should be the right height. Fire in a hole. So, metal moving. Rabbit's moving. This is moving. Everything's running this way. So there's your damming up Ed talks about. There's your damming up. So, and my whole wheel now has a beard. Boy, did I make a mess. Holy cannoli. Got some metal shavings in me too. Some battle wounds here. All right, guys. Hopefully you guys enjoyed the demonstrations. I think it's time to call this sucker a wrap. Leave your comments. Leave your comments. Peace out, my brothers. Peace out. Peace out. Somebody make sure you copy and paste up on the video. It'll be up in about 20 minutes. Peace out.